Dear students, welcome back. Now let us see the next property of the Fourier transform, that is the convolution property or theorem. If the Fourier transform of x1 of t is equal to x1 of omega and the Fourier transform of x2 of t is equal to x2 of omega, then the Fourier transform of x1 of t convolution x2 of t is given by x1 of omega into x2 of omega. That means the convolution of two signals in the time domain is equal to the multiplication of their Fourier transforms in the frequency domain. Convolution of two signals in the time domain, x1 of t convolution x2 of t, this is the convolution in the time domain. Then if you take the Fourier transform of it, that will be equal to the product of their Fourier transforms, that is in the frequency domain. Product of their Fourier transform, x1 of omega into x2 of omega. Let us consider the proof of this property. So we all know that x1 of t convolution x2 of t, x1 of t convolution x2 of t is equal to x1 of tau integral x1 of tau x2 of t minus tau d2. So we are taking now we can take the Fourier transforms on both sides. Left hand side Fourier transform of x1 of t convolution x2 of t, right hand side we are applying the equation integral minus infinity to infinity x of t e raised to minus j omega t. So here our x of t is the entire right hand side. Okay, this one is our x of t. So integral minus infinity to infinity, then comes our x of t, that is integral minus infinity to infinity x1 of x2 of t minus tau d tau into e raised to minus j omega t. So integral x of t e raised to minus j omega t dt. Now we can change the order of integration here in the right hand side. So I will take the first one, that is the integral minus infinity to infinity. Integral minus infinity to infinity. x1 of tau is taken here. x1 of tau is taken. Then comes here next integration. Integral minus infinity to infinity. x2 of t minus tau e raised to minus j omega t dt into d2. Okay, x2 of t minus tau e raised to minus j omega t dt into d2. So here we are substituting t minus tau as p, so that t is equal to what? P plus tau, dt is equal to dp. So we can see here the right hand side integral minus infinity to infinity x1 of tau into integral minus infinity to infinity x2 of p e raised to minus j omega instead of t, p plus tau dp, then comes d tau. Okay, so this e raised to minus j omega p plus tau can be split into two. So e raised to minus j omega p plus tau is what? E raised to minus j omega p into e raised to minus j omega tau. Okay, e raised to minus j omega p plus tau, e raised to minus j omega p, e raised to minus j omega tau. So this e raised to minus j omega p goes to the second function, that is x2 of t into e raised to minus j omega p dp എന്ന് എഴുതുന്നു. അതിനുശേഷം the first one is x1 of tau into e raised to minus j omega tau d tau. So we put it in this way. Okay, so in this way we are combining these two. So we can see here this is nothing but, what is it? This is nothing but x1 of omega into x2 of omega. This is as per the definition of Fourier transform. This is x1 of omega, x1 of tau e raised to minus j omega tau d tau. The variable is only tau, but that will be there we will be getting x1 of omega. Similarly, the second one, integral x2 of p e raised to minus j omega p dp, that will be equal to, instead of t here we have taken p. Okay, so that is equal to x2 of omega. So this one is nothing but what? x1 of omega into x2 of omega. So what is in the left hand side? The Fourier transform of x1 of t convolution x2 of t. So that is the convolution property or convolution theorem. So we can say x1, the Fourier transform of x1 of t convolution x2 of t is x1 of omega into x2 of omega. That is a convolution property. Thank you for listening.